Let's think about multiplying fractions now. As we saw with the whole numbers, multiplication as an operation has a fundamentally different character from addition or subtraction as operations. So it should not surprise us that the way that we multiply fractions is entirely different from the way that we add and subtract fractions. Let's suppose for a moment that we want to multiply, say, 2/3 times 5/4. Let's think about this the way that we thought about whole number multiplication, namely in terms of area. So I'm going to draw one number line, and on it I'm going to mark the thirds. And so this point will be 2/3. And at a right angle to that, I'm going to draw another number line, and on it I'm going to mark the fourths. And so 5/4 will be this point. Then 2/3 times 5/4 will represent an area. Namely, it's going to represent this area. So this area then is 2/3 times 5/4. What fraction is this? Well, first, let's look at one of these unit squares and see how many equal parts it's divided into. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each unit square is divided into 12 equal parts. Each of these little squares is a 12th. So this shaded part, the area that represents 2/3 times 5/4, it will be some number of 12ths. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 12ths. So 2/3 times 5/4 is 10 12ths. I could simplify that fraction, but I'm not going to at this time. How do we get that without drawing this picture? Well, look at how we divided up these squares. Each square is divided up into 3 columns and 4 rows. How did that come to be? The horizontal unit is divided into 3 equal parts. The vertical unit is divided into 4 equal parts. 3 rows, 4 columns, 12 parts. All right, then how did we know we were going to mark 10 of them? Well, on the horizontal number line we marked 2. And on the vertical line we marked 5. So we had 5 rows with 2 boxes in each row marked. We had 10 marked. So look at what our procedure was. We were multiplying 2/3 times 5/4 to figure out how many boxes the unit square would be divided into. We multiplied 3 times 4. To figure out how many of those boxes we were going to mark, we multiplied 2 times 5. And we got the 10 12ths that we counted in our picture. This is going to be our general procedure for multiplying 2 fractions. Again, this is completely different in character from our procedure for adding or subtracting fractions. But that's totally to be expected, because multiplication is completely different in character from addition and subtraction. And of course, once we've done the multiplication, we can simplify if we'd like. For example, our 10 12ths we could simplify as 2 times 5 over 2 times 6. The common 2's cancel, and we're left with 5/6. All right, I'm going to give you one of these to try, and I'm going to ask you to draw it out. Multiply 4/7 times 3/5 and draw your answer out on a grid to justify that your answer is actually correct. Pause the video and try this now. Alright, so I'm going to draw 2 number lines. My horizontal number line, I'm going to mark the thirds, and so here is 4/3. My vertical number line, I'm going to mark the fifths, And so here is 7/5. So 4/3 times 7/5 then represents this area. Each unit square is divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 boxes. I've marked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28 of them. So 4/3 times 7/5 is 28/15, which is what we would expect if we multiplied the numerators and multiplied the denominators. I'm going to have you try another one of these now that is inconvenient to draw out. Multiply 7/18 times 45/28, and do not simplify your answer. Pause the video and try this now. All right, we'll multiply the numerators and multiply the denominators. I think we're going to need to write out both of these multiplication problems. 45 times 7. 7 times 5 is 35. 7 times 4 is 28. 29, 30, 31. 18 times 28. 8 times 8 is 64. 8 times 1 is 8. 9, 10, 11, 12, 13, 14. 2 times 8 is 16. 2 times 1 is 2, plus 1 is 3. Adding these up, 4, 10, 1, 2, 5. 504 will be my denominator. I get 315 504ths. I hope you agree that we don't particularly want to draw that out. But this is exactly the same idea as we had for this multiplication.